Section 3.3 is on logarithmic properties. Okay, so they're going to introduce some of the properties. The first formula they introduce is the change of base formula. This is how your computer or your calculator evaluates a log that is not base 10 and is not base e. Okay, so if it's log base a of x, it's an unknown, it's a base your calculator doesn't know. If it wants to calculate it using common log or base 10, it does log x over log a. It's base 10. It's also called common log because we're a base 10 number system. The formula also works with ln x over ln a using the natural log, the ratio of natural logs. It actually works with any base. I could do log base 2 over log base 2 of x over log base 2 of a. It just happens that your calculator typically knows either common log or natural log. Okay, so for example 1, it says evaluate log base 3 of 40 using the change of base formula. And this is because, again, sometimes your calculator cannot evaluate a different base. If it does, it's actually using this formula. You can use either formula. You should get the same answer. So in your calculator, you could do log 40 over log 3. You might have to play with the parentheses. Or you could do ln 40 over ln 3. They're the exact same thing, so just pick one. I like ln because it's one less letter to write each time. Okay, and then you put it in your calculator and you should get about 3.358, okay? If you don't, try to put parentheses around the ln 40, parentheses on the ln 3 or something like that. And it does seem reasonable that 3 to the 3 point something would give me 40 because 3 to the third is 27. So it would have to be higher than 3. Okay, so now the log properties that you probably remember from last year are in this box right here. They will be in a box. Okay, the properties of logarithms are the exact same thing as the properties of exponents because logarithms are just another way to express exponents. So for the first property, log base a of u times v, if you are multiplying two things that have the same base, if you're doing exponents, you add the exponents. If you're doing logs, you add the logs. Okay, and then just like exponents, log base a of u over v, that's like if you have a to the 5th over a to the 2nd, you subtract the exponents. Because we're talking about logs, I subtract the logs. Okay, and the last one, sometimes called the power rule, the log base a of u to the n, you bring the n down to the front, and that equals n times log base a of u. Okay, we're going to use those properties to kind of play around with different expressions. Depending on the situation, sometimes you want to expand it into a sum or difference. Sometimes you want to condense it into a single log, single expression. So depending on the situation, you do whatever is going to be most convenient in this situation. Okay, so for example 2, it says rewrite each log in terms of ln2 and ln5. Okay, the first a is ln10. Okay, so first thing is I want to try to rewrite the argument using 2 and 5 somehow. Okay, well, ln 10, that's the same as ln of 2 times 5, because 2 times 5 is 10. Okay, once it's like that, I can use the properties of logs. If I'm multiplying the arguments, that is the same as adding the separate logs. So now my final expression is ln 2 plus ln 5. And I did succeed in rewriting my log in terms of ln2 and ln5. And if I knew the values of ln2 and ln5, I could evaluate it from here. Okay, for b, I'm going to do a similar thing. I just want to kind of rearrange it till I can get the ln5 and ln2 separated. Okay, this is a bigger expression, so I think I'm going to kind of expand it out first. Okay, so on the numerator, I have ln5. Okay, and then I have the times e to the fourth, so I'm adding ln e to the 4th. And since the 2 is at the denominator, if I want to separate this out, this is subtracting ln2. Okay, this is looking a lot better. I see that I have an ln5 here. I see I have an ln2 here, which are both good. This ln e to the 4th, I'm not allowed to have that on my answer based on the directions. Okay, so the ln5 is 5. Okay, now what is ln of e to the 4th? Well, ln and the e kind of cancel out, so this just turns into 4. Okay, this is a good final answer. The only logs in my answer are ln2 and ln5, and then I have the constant of 4, which is perfectly fine. Okay, I'm going to keep going. C, there's more than one way to do C. I think I'm going to rewrite it with an exponent because there's already a nice 2 at the top. I'm going to make this 5 squared. If you do it differently, I'll show you how to do it differently too. Okay, so if I want to rewrite this using the properties, it would be ln 2 minus ln of 5 to the second power. Okay, I'm close, but right now it does have an ln of 25, which is not allowed in the direction, so the ln 2 is okay. I'm going to use that last property where I can take this exponent and bring it down. So now I have minus 2 ln 5. Okay, so I have ln 2 minus 2 ln 5. The only logs in my answer are ln 2 and ln 5. So this is rewritten as I want it to be. Okay, as a side note, because some of you might have done it like this, you might have done ln and then made this 2 over 5 times 5, which is also fine. It's the same expression. I would have ln 2 minus ln 5 minus ln 5, which would be ln 2 minus 2 ln 5s, and I would get the same answer that way. So there's multiple ways to do it, but we should come up with similar final expressions. Okay, for example 3, we're going to condense into a single logarithmic expression, and this is commonly useful if we're trying to solve or something like that. Before you even start, make sure they're all the same base. This is log base 2 of 6, log base 2 of 7, and log base 2 of x. So I can combine them. If they had different bases, I would not be able to combine them easily. Okay, let's see. I'm going to use the log properties, but now I'm going backwards. Okay, I want to put this in a single expression. Okay, so I have log base 2 of 6 plus log base 2 of 7. Since I'm adding the logs, I must have been multiplying the arguments. Okay, I'm subtracting log base 2 of x, so I must have been dividing by x. I'm just going to simplify this a little bit because I can multiply. 6 times 7 is 42 over x, and this is better because this is written as a single logarithmic expression. I only wrote log once, and technically there's a coefficient of 1, so this is a single log. And if you did that, both of those steps in your head, that would have been fine with me. Okay, I'm going to do the same with example B. I want to rewrite it as a single logarithmic expression. Before I start applying those first two properties, because there's some coefficients here, I want to take the coefficients and move them back to the exponent spot before I start rearranging these into multiplication or division. Okay, so I'm just going to move the exponent up. So this is now 2 to the third. I'm going to move that 3 back up to the exponent spot, and then the last one was already fine. Okay, now I can see they're all log base 5, and they all have single arguments right now. Okay, now I'm going to carefully work this. Okay, now 2 to the third. Actually, 2 to the third is 8. I'm going to just put 8. Okay, since I'm subtracting the log of x minus 1 to the third, I am dividing by x minus 1 to the third. Since I'm adding log base 5 of x, I'm multiplying the argument by x. Okay, so this is my final answer. I can't really simplify it anymore. Don't multiply it out. It doesn't make it any better. If I could cancel something, I would cancel something, but in this case, nothing will cancel. And if you're a little confused about why that x is at the top, if you think about if I rearrange this, if I had done log base 5 of 8 plus log base 5 of x, it would have been more obvious that it would be 8x. And then I would have subtracted this, so it would have gone to the bottom. Okay, let's do one last condense into a single log. Okay, this one looks like this. It has some extra parentheses is all. Okay, there's more than one way to do these, keep in mind. So what I'm going to do first is, because there's these extra parentheses, I'm going to go ahead and combine these together first. If I combine those, since I'm adding the logs, I'm going to multiply the arguments. Okay, and then I'm going to keep the 1/2 in the front, and I'll bring down the minus. Actually, I could bring that 3 up now, but I'll bring it up later. Okay, now I'm going to go ahead and move the exponent up. Okay, just be careful because this 1/2 is applying to the entire expression. Now I'm going to go ahead and bring the 3 up here. Okay, now I'm going to try to rewrite this as a single expression. There is more than one way to write it. Okay, so I have x times x plus 5 raised to the 1/2. Because I know 1/2 is a square root, it is nicer to write it as a square root. It's not wrong to leave it as 1/2, but it's nicer as a square root. Okay, since I'm subtracting ln x minus 2 to the 3rd, I'm dividing the argument. Okay, that's my final answer, and that's about the best I can write it. Okay, for example 4, we're going to expand these, so we're going to take them out as far as we can. We want to have no exponents if possible at the end, and evaluate and simplify anything we possibly can. Okay, so I'm going to go factor by factor. Log base 4 of 4 plus log base 4 of x squared plus log base 4 of y. Okay, this is looking pretty good, but I still have the x squared, so I'm going to bring that down so it's expanded entirely. Okay, I don't want to have exponents at the end if I can avoid it. Okay, this is looking very expanded. The one thing though, if I see log base 4 of 4, I know what the log base 4 of 4 is. I do need to simplify. Log base 4 of 4 is 1. Okay, now I have expanded it and simplified it the best I can. Okay, one last one, and we're going to expand it again the best we can. Okay, this is an ln, so let's see. If I expand this out, I have ln of the 3rd root of 5x plus 1 minus the natural log of 4. If I have a radical, I really have an exponent, so I need to keep going until I can move the exponent. Since it's a 3rd root, the exponent is 1/3. ln 4, I can't simplify that. Okay, I'm going to bring the exponent down. And then this is going to be my expanded expression. Got rid of as many exponents as I could and simplified anything I could.